In this lesson, we will be converting standard to vertex form, and in example 2, we'll work backwards from that and convert from vertex to standard form. So let's take a look at example 1. It says, given each equation in standard form, convert to vertex form, and we have a hint. First, find the vertex. Just to give you a heads up, there is another method on how you can do this. It's called completing the square. And we're going to do it with this method instead, finding vertex first. But if you do get help from a tutor, or you get help online or with other resources or textbooks, you may see them using completing the square to convert standard form to vertex form. Since we've already learned, though, how to find a vertex in standard form, we're going to do it that way, because then we can use something we've already learned again instead of having to learn something brand new. So first, find the vertex. To find the vertex in standard form, we have x equals the opposite of b over 2 times a. So in this case, the opposite of b, which is -4, is a +4, and a is a 1. 4 divided by 2 is 2. If I plug a 2 in for x, I have a 2 squared minus 4 times 2 plus 1. So we need to simplify for y. 2 squared is 4, minus 8 plus 1. That's -4 plus 1, which is -3. So we have found the vertex, 2, -3. And now we just want to write in vertex form. So question is, what's the a? Okay, because vertex form is going to look like this. A times x minus h squared plus k. We just found the vertex, which tells us what to plug in for h and what to plug in for k. But what do we plug in for a? Well, since we do have the equation in standard form, can't we just look at what a was in standard form? And in this case, a is 1, so we just use 1. So we're going to have y equals a 1, which you don't need to put there, in parentheses. Then we'll have x minus 2 squared, and then a -3. All right, let's do the same thing now for part B. We have an equation in standard form. A is 1, b is 2, c is 0. So to find the vertex, x equals the opposite of b over 2 times a. -2 divided by 2 is -1. To find the y, I'll plug the -1 in everywhere I see an x. And when I simplify this, -1 squared is 1. 2 times -1 is -2, and 1 minus 2 is -1. So for the vertex, I'm getting -1, -1. Once again, the a is 1. That's our lead coefficient in front of the x squared. So when I write this out in vertex form, I have y equals x minus -1, which is x plus 1 squared, and then a -1 at the end. In our next example, the directions say, given the equation in vertex form, convert to standard form. All we're doing here is some algebra. We're going to FOIL by squaring a binomial. We're going to use distributive property. We're going to combine like terms. All right, so once again, we have vertex form here. The a is -2, the h is -3, and the k is -4. The first thing I want to do is look at this x plus 3 squared. So I'm not going to do anything with that -2 yet, and I'm not going to do anything with that -4 at the end yet. But in the middle, this x plus 3 squared, I'm going to write that out twice, and I'm going to take care of that part first. Okay, so I have y equals, and with x plus 3 squared, I have an x squared plus a 3x plus a 3x plus a 9. And I guess I didn't need a bracket there. I can just use parentheses. Within those parentheses, I can simplify by combining the 3 x's together. So if I combine those like terms, I have x squared plus 6x plus 9. And then I still have the -4 at the end. All right, what do I need to do next now? Well, we'll follow order of operations. With order of operations, we multiply before we subtract. So we'll distribute this -2 next. So when I distribute negative 2 to all three terms, I have y equals negative 2x squared minus 12x minus 18, and then I have a minus 4. So my last step is to combine like terms, and negative 18 and a negative 4 can combine. So y equals negative 2x squared minus 12x minus 22. And there is our final answer. So I'm just going to put a box around it. That's what goes here. I'm not going to rewrite it. But that's how we convert from vertex form to standard form. So once again, I started by squaring the x plus 3 to get x squared, excuse me, plus 6x plus 9, and then distribute the negative 2, and then combine the negative 4 at the end. All right, last example on this lesson here says, given the vertex, write an equation in standard form. So standard form is y equals ax squared plus bx plus c, like we just got in our answer above. It's giving us a is 1. And since we have the vertex, but we want it in standard form, the hint says to use the vertex to write in vertex form. So we'd have y equals x plus 2 squared plus 1, and now convert. So the last step here of converting is what we just did above in example 2. Why don't you hit pause and try to finish up this problem? And once you have an answer, hit play to check and see how you did. All right, so to convert from vertex form to standard form, we have to multiply x plus 2 by itself. So when we FOIL that, we're going to get x squared plus 2x, which is plus 4x plus 4. And then we have a plus 1. So that's x squared plus 4x plus 5. And there's your final answer on example 3. All right, so in example 1, we started with standard form, converted to vertex form. And basically in examples 2 and 3, we worked backwards and started with vertex form and converted to standard form. So it's very important to know the difference between vertex and standard form, and now you also know how to convert from one to another. And eventually we'll also talk about a third form called intercept form.